All right, so we've now seen or statements and we've seen and statements, but now we're going to go ahead and talk about them in one part. So we're going to review both of those. What I'm going to do is just do some examples with those. Now, we're going to graph and write all ands as a triple. So we'll start out with one of those just as an example. What is a triple? Well, it's when we have the two inequality signs with the x between them. So we're going to write all our and statements as a triple. Let's just go ahead and graph this one for practice again. We have 3 on our number line and 5 on our number line. This one says that x has to be greater than or equal to 3. So colored in dot, greater than 3. The second part here says that x is supposed to be less than 5. Our and statements is where they are both shaded. So you can see in this problem that I had an open dot on 5 and a closed dot on 3. And they're both shaded in between the 3 and the 5. So that is my solution set. Let's go ahead and jump to what an or statement looks like. It's straightforward what's an and an or. It'll say the words or it will say the words and, or it will appear as a triple, which is an and. So in an or statement, this is already solved for, so all we're going to be doing is graphing this one. I'm going to make sure I place 3 on the number line and 1 on the number line. Remember, or statements is it just has to fit one or the other, or it could fit both of them. But it just has to fit one of the cases. So we just go ahead and graph it. We don't have to think about where it's shaded in both parts or anything like that. So A is less than 1. So we're going to go less than 1, or A is greater than or equal to, colored in dot, greater than or equal to 3. Remember, or statements look like those outer edges are shaded. That is what they look like the majority of the time. On the next one here, we have another and statement. And this is, I know it's an and statement because it's a triple. I'm going to go ahead and draw lines down from each inequality. We're going to get rid of the add 6 by subtracting 6 on all 3 parts. I get negative 2, bring down my sign, 2x, bring down my sign, and I have negative 16. Divide by a positive 2 everywhere, and not flipping the sign. Now, if you remember, if we go back to all these other and statements, and I'll just bring up this one, look how my signs are. They're less than signs. They've always been less than signs. If you go look at all the examples, they've always been less than signs, not less than signs. So this one, when they don't have less than signs, we've got to make this look better. How else do I know it's not quite right? Well, my number line, negative 8, is over here. And negative 1 is on the right-hand side of negative 8. So what I'm going to do is I'm actually going to flip-flop all of this stuff around. So I'm going to move my negative 8 down here, and I'm going to move my negative 1 down here. And what happens, see how the sign is pointing at the negative 8. So I'm going to make my inequality still point at the negative 8. So it says that x is greater than negative 8. And on the other one, I'm going to make my inequality point at the x. So it says x is less than negative 1. This is the correct way to write that triple. So what we're going to do is we're going to go ahead and put our open dot on negative 8. We're going to say that it's greater than negative 8, and it has to be less than negative 1. So it will be the shaded region in between negative 8 and negative 1. That is the typical looking and statement.